When I started studying physics, I wanted to understand the world around me. Physics is just as fascinating and mysterious at the scale of a cell as it is at the scale of a galaxy.
What we find very exciting is that the stage in which we work, the potentials are vast.
Let's go to the basics. How can we understand this problem, and how can we come up with the equations that will describe it in the end?
The question is there anything beyond that?
Can we really push the limits of physics?
It's really trying to see if there's any more secrets behind the physics we know already.
And by looking ever and ever more precise, you hope to also find something that maybe you don't understand.
So that, I think, is rewarding.
It's like people being more on the fundamental side, people being more on the applied side.
We really are a multidisciplinary group that tries to bring this together.
That's what is fascinating for me. We're really at the crossroads of all these disciplines.
And once you get things together, the whole picture starts to appear in front of you like a puzzle, just bits and pieces.
And then bang, everything clicks. All these Lego pieces start joining together.
As a physicist, we can look at beautiful systems, how the stars work, how black holes work.
We have our best theory of nature, which is called the Standard Model of Particle Physics, and this makes very specific predictions. And this is something that requires combining together a huge number of measurements.
There's a lot you can do with the data, but there are going to always be signals that are outliers.
There are a few things that we cannot explain, and this is, for example, dark matter and dark energy.
This can give us some deep insight into cosmic history, into how the heavy stars that made the elements that we are made out of were formed in the first place.
And I find that there's this huge universe inside a living cell, this intricate factory with little proteins that each do their job.
What I find really cool is that you can understand these systems not from a biological perspective, but from a physics perspective.
The materials that we study and the mechanisms that we study are largely inspired by the process of natural photosynthesis.
Photosynthesis is known as the most important reaction on Earth.
We are studying the light reaction, so how light interacts with the matter and how this is transforming chemical energy.
So if you would zoom in on a leaf of a plant, you will find the cells. I like to take those machines out of that leaf, out of that cell, and apply it directly onto new solar cells.
In order to be able to improve the process for agriculture and hopefully at some day also for harvesting the light into biofuel.
We think light is a wave. Fundamentally, it's a particle, but we describe it with wave equations.
So there the fundamentals comes into play. It's like a toolbox, the magical toolbox, and you need lots of variables to be able to make this toolbox really applicable for different applications.
We can also find traces of life on Mars, or we can understand why polymer materials start getting brittle after a number of years and fall apart.
We can visualize cells, cell nuclei, connective tissue, everything that is needed for a diagnosis.
It gives your work basically purpose that can be used by ideally lots of people in the future, even long time after I don't do research anymore.
So to me this is progress, to me this is beauty. That some people find beauty in art, in music, in various other contexts, but science is beautiful.
And that's what really keeps me going, is you want to understand all this beautiful physics, but then sometimes it'll just completely take you aback, throw you off your feet.
And in all of the research we do, you very easily find the fundamental question, and all the researchers here, they can actually answer the question, what is it good for? And this is a very strong motivation to do your research.
I realized that society is paying me to do this. And in a way, I want to pay back society with my research effort. I would like it to have an impact on society and be beneficial.
I don't want to operate in a vacuum, not interacting with the rest of the world. I would like to inspire my students and the world.
Applications that might find their way into the world are then a decade away. This is not something that we will do as a physicist, but it's something that we want to show the world, hey, this is possible. Let's take this idea further.